Hi there. So, anybody who watched a review of this Mastercraft multimeter, you may remember that it was made by Intertech. It was simply rebranded. And today I was in at the dollar store, and I noticed this outlet tap here that has a pair of USB charging ports on it. Interesting thing is, especially when it comes from the dollar store, you got to wonder. I mean, it wasn't a couple bucks. It was $12, which is still not that bad. When we flip it over, Intertech. So I'm not sure if they've actually made this, and if they have, there might actually be a decent quality. So going to give it a test. It claims 2.1 amps output. That's combined. So we'll see if it indeed can do that, and hopefully it's easy to take apart and I can pop her open and take a look at the construction quality as well. Alright, so yeah, it looks like it's just the 4 screws pushing on it. It doesn't feel like it's glued, so hopefully this will be easy to pop open. It wasn't just the packaging, it is marked Intertech, so we'll pop her open and see what's inside. Alright, and I'm in. So the outlet portion here, this is pretty much what I expected. That's pretty standard. But what we're interested in is up in here. And so it looks like they've used multi-board construction. See a lot of residue in that on the board itself. It hasn't been cleaned very well. Looks like some flux residue in that, but you know, bit of glimmer of hope there. You know, there's an isolation slot. Yeah, no surprise. I mean, the bus bars here for the mains for the outlets, you know, they just soldered onto those. First thing I noticed is I went to go undo these screws and they've already been stripped, and I mean, it's in there tight. That the hole is too small for the size of screws. And if you look at this one, you can see that actually the solder mask is rubbed off on this trace here, where that hole cuts through. But then there's another track running right along the edge of the board, along here and up here. And I wound up never finishing the video, but I did have a Mastercraft branded non-contact voltage meter, which was also made by Intercell, and this is you know, the construction quality was quite poor on it, and you know, that's what I'm seeing here. You know, stuff like this here where you don't have a trace that close to the edge of the board. So we've got our AC coming in, and it looks like they've got, you know, a decent common mode choke there for noise suppression. There is a fuse on the board. They put some heat shrink tubing over it, but they didn't bother to shrink it. So it's an SD6834 under there. We've got just a single single diode rectifier with filter cap, and we've got an inductor. On the back, on the secondary side, there's not a whole heck of a lot. There's one SOT 23 package marked IC3, but I mean, other than that, it's just a couple passives, so nothing really much there. So I don't expect a whole heck of a lot on this other board. I don't even think it's really worth taking out. Not really worth ripping that apart any further, so I'm going to put this back together. I'm going to test it out and see how it performs. So just another quick note here, something I noticed when I was putting it back together. I don't think I can get in there and see, but you might be able to see how that plastic standoff is just bulging. These screws are definitely too big. The other thing is, because the solder mask had been peeled away, I checked on a couple ports, couple different points there on each of these two traces. They are showing as being electrically connected, although I don't see them joining up, and it is a single-sided board, so I'm going to assume that they are, because it's showing up as being just a short between them, that'll be the inductor joining across that. So basically whatever filtering you would have been getting from that inductor, you're not going to, because that inductor is being shorted out by that screw. So it should still work, but may cause some noise in that. So we'll see. Have to hook up the oscilloscope to this thing and you know, just measure the output noise and see how bad it is. Alright, so I got the test set up here now. It's very similar to what I had last time. So we got the output here hooked up to this dummy current with I've got the oscilloscope probe hooked up right here. Here showing the output. I have it DC coupled, so we'll be able to just monitor the voltage here. So I've got the mean voltage and then the peak to peak, so we can see what kind of ripple we're getting at different loads. So this meter here is hooked up to this little loop that, like I said, is just to allow me to measure the current. So it's 1 volt per amp, so whatever it's reading here in volts, we have an amp. So same thing, whatever it's reading in millivolts is our current in milliamps. So it's pretty straightforward. The only other difference with this and the other current sink I had been using is I went and put this, I think it's like a 20 or 25 turn trim pot on there instead of the big knob potentiometer single or 3/4 of a turn, whatever they are. Don't know if I really need the fine control, but anyways, we will let's begin testing this thing. So we'll flick the current source on, and I have it set here for about 100 milliamps, so you know, not much of a current draw, and as you can see, there's not much of a change in the peak to peak there, in the voltage ripple, and the output voltage is staying fairly steady, which is about what you expect. So we'll slowly start to turn this up and just see where it goes. Well, it looks like it's maybe lagging a little bit with the regulation there. Voltage seems to be dropping every once in a while, but that could just be some anomaly. So there we go, we're getting up to 380. No, it's still good. So as we approach 1/2 amp here, it's close enough to 1/2 amp. We can see we still have 5.2 volts, 160 millivolt peak to peak. Although it's jumping back and forth between 80 and 160. So not too bad. We're starting to see a little bit more noise in that, a bit more ripple, but not really we'll have to do this again after see the dropout point and everything. I'll repeat this with the scope AC coupled, so just starting to drop below 5 volts as I'm approaching the 2 amp mark here. USB specs do allow for a slightly lower, a bit of sag in the voltage or in the power rail. But at this point, if you had a cheap USB cable, you'd be seeing your losses dominated by the resistance in the wire. Alright, so yeah, I knew I was going to be pushing these sense resistors right to their limit, and I was actually overloading them a bit, and they're just getting too hot, so I can only do this in short bursts. I thought I would have a bit more time before they were overheating there, but I'm going to have to just quickly show this. So I got it set to about the 2.1 amp mark, and yeah, as you can see, it's doing fine. It's not cutting out. So alright, so here we go. I've changed the scope now to AC coupling. It wasn't quite making it to 2.2 amps. It was about 1.16, 1.18, and it was dropping out. It seemed to fluctuate a bit. It wasn't super consistent. Let's see what kind of ripple we get in that. So there's our bit of switching noise coming through. There's our peak-to-peak ripple showing roughly the same. I mean, we're getting better resolution now that I've been able to zoom in on the vertical. So let's go ahead, fire it up, and see what happens, and I'll just keep cranking it up. So there we go. No surprise, a bit of load does help. To rip that thing back apart and take that one screw out that I said was shorting out that inductor, and just see what kind of difference that makes, having that in there for filtering. So maybe I'll stop right now at we'll say about 1.2 amp load, and I'm going to stop, just quickly rip the thing apart and see what difference that makes. Okay, so here's the screw. I simply removed it and then put the unit back together. So let's just plug her in and see what we get here. We'll turn on the current sync, and yeah, I'll have to go back and look at the video, but that doesn't look like it really made much of a difference. So yeah, the noise, not exactly impressive. So let's just see how much power this thing is going to suck back. So it looks like this meter, either it's out, or I'm assuming that's it's just measuring the amount of power that it's consuming itself. So we'll see when we plug this in. Be a bit of a surge, and we'll wait. 0.4, it was reading 0.2, so it looks like we're using about 0.2 watts in standby. And I'll just really quickly pull this back over here and plug this guy back in, and it was, I believe, drawing about 1.2-ish. Let's see if I can get that so we can see. So we'll turn it on, and that's 8.3 watts at 1.2 amps times 5, so 6 watts output, and we're taking 8.3 in. I'm just going to go quickly write all these numbers down so we can do the math after. Alright, and I had to unplug it to get at the buttons, but I've now switched it so that it's reading current, and also at the bottom number here is the power factor. So we'll see how well it does here. Turn it on. 0.55. So 1.2 amp, and we'll say it was roughly 5.2 volts. 1.8 watts was the consumption, was 1.8. 8.3 was what it was reading, minus the 0.2 residual. So calculate that. That's 6.24 watts. Output with 8.1 watts in, 77% efficiency with power factor of 0.55. Till next time.